Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about isometric projections of the solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with orthographic front view projections and orthographic top view projections of the solid, and using the information available with us through these two orthographic projections, we are required to obtain the 3D isometric projections of the solid, into which the front view face, the top view face and the side view face of the solid should be appropriately combined into a single 3D isometric projection over here. In order to obtain the isometric projections of the solid, we need to obtain the dimensions of the front view face, the top view face and the left hand side view face of the solid. Now when we are going to look at the constructional details of this object, so we observe that length of the solid, it is equal to 110 millimeter. Now we can check, this is the length of 80 millimeter which has been provided to us up to this portion from the left hand side face of the solid, and thereafter we have got a circular portion having radius is equal to 30 millimeter. So the total length of the solid will be equal to this radius of 30 millimeter plus this linear portion of 80 millimeter. Regarding the height of the solid, we observe that the height of this horizontal web of the solid, it is equal to 20 millimeter. Height of this portion of the solid, it is equal to 10 millimeter, and then this radius of the outer circular portion, it is again equal to 30 millimeter. So the total height of the solid will be equal to 30 millimeter plus 10 millimeter plus 20 millimeter equal to 60 millimeter. So therefore the front face of the solid will be measuring 110 millimeter length of the solid and 60 millimeter height of the solid. Similarly, when we are going to look at the solid from the top, so we observe that the length of the solid, it is equal to 110 millimeter, while the width of the solid happens to be equal to 60 millimeter. So the dimensions of the top face of the solid will be equal to 110 millimeter length and 60 millimeter width of the solid. When we are going to look at the solid from the left hand side view, so we observe that the width of the solid, it is equal to 60 millimeter, while the height of the solid, it is also equal to 60 millimeter. So from the left hand side orientation, we are going to obtain the dimensions of the side view face as a square having dimensions is equal to 60 millimeter by 60 millimeter. In order to obtain the isometric projections of the solid, we need to convert all the true lengths corresponding to the various elements of this particular solid into the isometric length projections over here. So how do we convert the true length from these orthographic projections into the isometric length projections over here? So we have to draw the datum line or the baseline. From this particular corner point, we have to draw a true length scale inclined at an angle of 45 degree with respect to the baseline or the datum line. And now we have to make markings onto this true length scale, and the maximum dimension which has to be marked alongside this true length should be the longest dimension involved into this particular problem over here. So since the longest dimension is alongside the length of the solid, which is equal to 110 millimeter or 11 centimeter over here, so we have marked a length of 11 centimeter alongside this true scale over here. Then we need to draw an isometric length scale inclined at an angle of 30 degree with respect to this datum line or the baseline over here, and then corresponding to all of these true length dimensions which are involved into this problem, we have to draw vertical projector lines from the true length scale onto the isometric scale over here, and corresponding isometric length dimensions we are required to use while construction of isometric projections of this solid over here. So let us now evaluate on which side of the isometric axis we are going to obtain the front view face, the left hand side view face, and the top view face over here. Now here we have got three isometric axes with us. This is our datum line or the ground line. Now we have to take a center point. From the center point, as we move along the left hand side orientation at an angle of 30 degree, here we are going to obtain isometric x-axis over here. From the center point, as we move towards the right hand side orientation at an angle of 30 degree, so this axis we have named as isometric z-axis over here. And this vertical axis, this will be depicting the height of the object, and this isometric axis is called y-axis over here. So now we can check. We have marked the length of the solid alongside the isometric z-axis, and this length is equal to 110 millimeter. We have marked the width of the solid equal to 60 millimeter alongside the isometric x-axis over here, and we have marked the height of the object equal to 60 millimeter alongside the isometric y-axis. And now we can check the front view face of the solid will be measuring 110 millimeter length and 60 millimeter height of the solid. Left hand side view face of the solid, it will be measuring 60 millimeter height and 60 millimeter width of the solid. And the top view face or the bottom face, it is going to measure 60 millimeter width, and it is going to measure 110 millimeter length over here. So this way, front view face, side view face, and the top view face we have appropriately located into the isometric projection view over here. So now, in order to obtain the isometric projections, so first of all, we need to convert all the true length dimensions into the isometric length projections over here. So now, here we have drawn the baseline or the datum line, and we have to obtain a center point over here. And now from the center point, as we move along towards the left hand side inclined at an angle of 30 degree, isometric x-axis has been obtained. From the center point, as we move along right hand side direction inclined at an angle of 30 degree, isometric z-axis has been obtained. And as we move along the vertical direction, the isometric y-axis has been obtained over here. So now we know that as we look at the solid from the front view orientation, so the length of the front face, it is equal to 110 millimeter. So we have marked a distance of 110 millimeter from the center point. So the length of the solid we have projected equal to 110 millimeter alongside isometric z-axis over here. Similarly, if we want to draw the left hand side view face of the solid, now the width of the object equal to 60 millimeter has been plotted alongside isometric x-axis over here. So now when we draw another isometric projector line starting from this point, which is at a distance of 60 millimeter from the center point over here, now this isometric projection line measuring 110 millimeter and parallel to the isometric z-axis we have to draw, and another isometric projection line we have to draw from this point, which is at a distance of 110 millimeter from the center point. And this isometric projection line, this will be parallel to isometric x-axis over here. So this way, this base of this solid, it has been appropriately located into the isometric projections over here, and it is going to measure 110 millimeter length of the solid and 60 millimeter width of the solid. And now we know that alongside the y-axis, that is height of the solid, has to be projected over here. So now this isometric distance of 60 millimeter we have marked above this particular center point over here. So now this distance will be 60 millimeter, which is going to indicate the height of the solid. And now once we draw another isometric projector line having height is equal to 60 millimeter parallel to this isometric y-axis, so we are able to obtain the height of the solid over here. And then once we draw another isometric projector line over here parallel to this isometric x-axis, now the left hand side view face of the solid measuring 60 millimeter width of the solid and 60 millimeter height of the solid has been appropriately obtained over here. And once again, if we draw a vertical isometric projector line having height is equal to 60 millimeter from this point, and this isometric vertical projector line will be parallel to the y-axis. Now if we join this point with this point, so we are going to obtain another isometric projector line having length is equal to 110 millimeter, and this isometric projector line will be parallel to the isometric z-axis over here. So this way the isometric front face of the solid, it has been appropriately obtained into the isometric projections, and we can check the dimensions over here. It is having 110 millimeter length of the solid and 60 millimeter height of the solid. Now in order to complete the top face of the solid, another couple of isometric lines need to be drawn over here. One isometric line we have to start from this point parallel to the z-axis, or this isometric projection line measuring 110 millimeter needs to be drawn over here, and another isometric projector line parallel to the x-axis, or this isometric projection line measuring 60 millimeter needs to be drawn over here. So this way the top view face of the solid has been appropriately obtained over here. Next, once we draw another vertical isometric projector line measuring 60 millimeter joining these two endpoints, so now we can say that we have obtained the cubical construction corresponding to this solid, which is going to depict the front view face, the left hand side view face and the top view face of the solid into the isometric projections over here. Now let us evaluate different elements of the solid into this 3D isometric construction over here. So we can now divide this solid into two parts. The first part of the solid, it is this horizontal web over here. So into this horizontal web, we know that, so this portion happens to be equal to 40 millimeter. This portion happens to be equal to 60 millimeter. So we have obtained this portion of the solid equal to 10 millimeter. So we can say that this horizontal portion of this web, which is resting onto the ground, it is having length is equal to 50 millimeter. And thereafter we will have element number 2. Into the element number 2, we have got two vertical circular webs. One vertical circular web is lying towards the front face of the solid. Another vertical circular web, it is lying towards the rear face of the solid. And both of these webs, they are having thickness is equal to 20 millimeter. Whereas in between there is a gap of 20 millimeter over here. Similarly, onto the front side also, here we have got a rectangular slot which is having thickness is equal to 20 millimeter over here. So now we know that corresponding to this element number 1, which is a horizontal wave, this is having length is equal to 50 millimeter and height is equal to 20 millimeter. So now this 50 millimeter by 20 millimeter block we have to draw towards the left hand side face of the solid. So towards the left hand side face of the solid, we are going to obtain this flat horizontal web over here. So now we know that this height is equal to 20 millimeter. So at a height of 20 millimeter, we have obtained an isometric projection line which will be parallel to the isometric x-axis over here. So now we know that corresponding to this horizontal web, again we have got two portions of this horizontal web. So one portion is this rectangular slot, then we have got 10 millimeter portion corresponding to this surface area. So now we are going to measure length of 40 millimeter and 50 millimeter from the center point. So we have measured a length of 40 millimeter and 50 millimeter over here alongside the isometric z-axis over here, so that these two end points we are able to locate appropriately into the isometric projections over here. Now we have to draw a vertical isometric projection line corresponding to this cross section over here of the horizontal web. So now we have drawn a vertical projector line which is parallel to the y-axis, having height is equal to 20 millimeter over here, and then from this point we have to draw another isometric projection line having width equal to 60 millimeter, which is going to depict this width of 60 millimeter into the orthographic projection view over here. So now into the isometric view we have drawn this isometric projection line having width is equal to 60 millimeter, and this isometric projection line happens to be parallel to the isometric x-axis over here. So from this point, once again we have drawn another isometric projection line which is measuring 50 millimeter length, and this isometric projection line happens to be parallel to this isometric projection line as well as this isometric z-axis over here. This way, this flat block corresponding to the horizontal wave located at the base of the solid has been appropriately obtained over here. Now, corresponding to this portion, that is up to this rectangular slot, so this portion is lying at a distance of 40 millimeter from the left hand side face of the solid. So now from the left hand side face of the solid, which is this portion, we have to measure a distance of 40 millimeter, and again one vertical isometric projection line having height is equal to 20 millimeter corresponding to this portion. It has been obtained parallel to the isometric y-axis, and another isometric projection line measuring 60 millimeter width parallel to the isometric x-axis has been obtained over here. So this way, this flat portion corresponding to this portion of the solid, it has been appropriately located into the isometric projections over here. Now let us locate this portion and this portion corresponding to this horizontal web over here. So we can see that there are two cross sections over here. That width of the solid is 60 millimeter. So this width is 20 millimeter. This width is also 20 millimeter, and this rectangular slot width, it is also equal to 20 millimeter. So now we know that we have got both of these webs located symmetrically around the center of the solid alongside the width of the solid. So total width of the solid happens to be 60 millimeter. So we'll find out the midpoint. From the midpoint, we'll take an offset of 10 millimeter towards the left side, 10 millimeter towards the right side, so that from this point, so we are able to obtain this rectangular slot located at the center of the solid alongside the width of the solid, and then 10 millimeter offset corresponding to this web surface, 10 millimeter offset towards the front side corresponding to this portion of the web we are going to locate. So now we can see, as we look from the left hand side, from the center point, 10 millimeter offset and 10 millimeter offset. So this will provide us with these 2 points, that is 20 millimeter rectangular slot width over here we have been able to obtain corresponding to this portion of the web and corresponding to this portion of the web. So this is 10 millimeter and this is 10 millimeter. So these 4 points we have been able to locate symmetrically alongside the width of the solid. And now from these 4 points, again 4 vertical isometric projector lines having height is equal to 20 millimeter, we are going to obtain in such a way that these 4 vertical isometric projection lines, they will be parallel to isometric y-axis over here. So this way, this surface and this surface, it has been translated into a 3D isometric projection surface over here into these isometric projections. And now corresponding to this vertical surface, we know that this web, it is going to continue towards the rear side of the solid. So now another isometric projection line from this point up to this position over here, parallel to the z-axis, we have obtained over here. Now if we look at the geometry of the object, so we observe that from this point and from this point, so these 2 projector lines, these 2 vertical surfaces that we have obtained, they are parallel to the front face and the rear face of the solid. That is from this point and this point. So 2 isometric lines we need to connect up to this distance of 40 millimeter parallel to the z-axis over here. So please check this blue projector line and this blue projector line. So these 2 isometric projector lines we have drawn parallel to this isometric z-axis over here, or parallel to this vertical outer surface of the solid over here. So now this surface and this surface, it is parallel to the outer surface. So this is an isometric projector line measuring length is equal to 40 millimeter, and this is also isometric projector line measuring length is equal to 40 millimeter. We can check this length is 40, this length is also 40, but we cannot say the same thing regarding these 2 slanted edges, because this slant edge starts from this point, it goes up to this particular point at a distance of 50 millimeter from this surface over here. Similarly, this inclined edge, it starts from this point and it ends at a distance of 50 millimeter from the left surface of the solid. So this distance will be greater than 50 millimeter. This distance is greater than 50 millimeter. Moreover, this inclined surface and this inclined surface, so both of these surfaces, they are not parallel to the front face of the solid or the rear face of the solid. So we have joined this point with a point which is lying at a distance of 50 millimeter from this surface, and the width between these 2 endpoints, it is equal to 60 millimeter, whereas the distance between these 2 points, we can check, it is only equal to 20 millimeter. So this distance is 20 millimeter, whereas this distance is 60 millimeter. And since this projector line and this projector line, it is not parallel to the z-axis, so this is a non-isometric projection line. This is also a non-isometric projection line because it is not parallel to any one of the isometric axes over here. So this way, the left hand side portion of the solid up to a distance of 50 millimeter, it has been obtained into the isometric projections over here. So now we are left with this portion of the solid. So this portion of the solid, if we evaluate, so we can check length is equal to 60 millimeter, height is equal to 60 millimeter, and width is also equal to 60 millimeter. So if the length, width and height, all 3 of them corresponding to the 2 vertical circular webs, it is equal to 60 by 60 by 60. So now here we have obtained a cube structure over here. You can check, if we draw these isometric projector lines parallel to the isometric axis, we will be obtaining, even we are going to join this one. So we are going to obtain a cube construction over here. This is a cube which is having dimensions 60 millimeter length, 60 millimeter height and 60 millimeter width over here. Corresponding to this particular portion of the solid, here we have got two vertical circular webs over here carrying a circular hole. This is first web which is lying toward the rear face of the solid. This is second web which is lying towards the front face of the solid. And both of these webs, they are having width is equal to 20 millimeter and there is a gap of 20 millimeter between these two webs. So now here we have got two circular projections over here. The outer circular projection is having diameter is equal to 60 millimeter and the inner circular projection, it is having diameter is equal to 40 millimeter. So we can obtain the circular projections in the isometric projections when we inscribe these circles into the squares over here. So the outer square is having edge is equal to 60 millimeter. The inner square is having edge is equal to 40 millimeter. And we know that whenever we want to transform the circular projections into the isometric projections, they will be appearing like an ellipse over here. Similarly, when we want to transform the square projections from the orthographic projections into the isometric projections, we are going to obtain a rhombus shaped projections over here. So we can see, even though this is a square of 40 by 40, but the two diagonals, they are not equal. This is the major diagonal which is a bigger diagonal. This is a shorter diagonal which is a minor diagonal. So it appears like a rhombus. So before we start with construction of these four vertical circular surfaces over here, let us proceed to evaluate four square projections into this isometric projection construction over here. So this is first face, that is the rear face of the solid, which is a square. So now at a distance of 20 millimeter, another square projection now we are going to obtain. So at a distance of 20 millimeter, we can check one isometric projection line measuring 60 millimeter over here, another isometric projection line measuring 60 millimeter over here at a distance of 20 millimeter from the left face of the solid. It has been constructed, and these two isometric projections measuring 60 millimeter have been drawn parallel to the isometric z-axis. Similarly, these two vertical isometric projections having lengths equal to 60 millimeter have been drawn parallel to the isometric y-axis over here. So this way, this vertical square surface and this vertical square surface has been obtained. Similarly, one vertical square surface on the front side, it has already been obtained over here corresponding to this surface. So now 20 millimeter from the front face, 20 millimeter from the front face, 20 millimeter from the front face, again 20 millimeter from the front face. So again 4 points will be located over here, and once again we are going to obtain 4 isometric projector lines, each of them measuring 60 millimeter. So this isometric projector line and this isometric projector line measuring 60 millimeter have been drawn parallel to z-axis. This vertical projector line, this vertical projector line measuring 60 millimeter have been drawn parallel to the isometric y-axis over here. So now 4 square surfaces, they have been obtained into the isometric projection. First square surface, second square surface, third square surface and the fourth square surface. Now into these 4 square surfaces, now we have to obtain these circular projections corresponding to these circular webs over here. So now we know that in order to obtain circular projections, we have to inscribe a circle into a square over here. So since the outer circle is having diameter is equal to 60 millimeter, so the square should be having the size equal to 60 millimeter. So this square, it is having size is equal to 60 millimeter. Now using the 4 center method, we are required to obtain the circular projection which will be appearing like an ellipse into the isometric projections over here. So what we have to do, now we know that when we obtain a square into a isometric projection, it appears like a rhombus, and into this rhombus the midpoint of all the edges have been obtained over here. And we know the characteristic of the rhombus. If we join the opposite corners, so we are going to obtain minor diagonal and the major diagonal of this rhombus. Now from the each end point of the minor diagonal, we need to join midpoints of the opposite edges over here, and similarly from this end point of the minor diagonal, again the midpoints of the opposite edges need to be joined. So now here we have got four centers. Center number 1 end point of the minor diagonal. Center number 2, another end point of the minor diagonal. Center number 3, it is this intersection point. Center number 4 is this intersection point. Now from the first center point, we will open the radius is equal to this one, or we will open the radius is equal to this radius, and from this center point one arc we are going to draw through the compass over here, and through the second center point we are going to use this radius or this radius, and through this center point the second arc we are going to draw over here. Then through the third center point we'll use this radius or this radius, and the third arc we are going to draw over here. And similarly through the fourth center point, this radius or this radius we are going to use, and the fourth arc we are going to draw over here. So we can check through this center point, first arc has been obtained. Through the second center point, second arc has been obtained. Through the third center point, third arc has been obtained, and through the fourth center point, fourth arc has been obtained. So now the outer circular portion corresponding to the front face of the solid has been obtained. Now we need to obtain the inner circular portion. So we know that the diameter of the inner circular portion happens to be 40 millimeter. So we have to inscribe the circle into a square of 40 millimeter edge. So how that will be possible? Take an offset of 10 millimeter, offset of 10 millimeter, offset of 10 millimeter, and offset of 10 millimeter towards the interior side from the outer surface of the square. So this square of 40 millimeter size will be obtained. So over here 10 millimeter offset on the inner side, 10 millimeter offset on the inner side, 10 millimeter offset on the inner side, and 10 millimeter offset on the inner side has been obtained. So this is a square of edge 40 millimeter, which once again appears like a rhombus. So once again we'll take the midpoints of all the four edges over here and join the opposite ends of this particular rhombus, so that a major diagonal and a minor diagonal is obtained. Again using the four center method, that is, join each one of the endpoints of the minor diagonal with the opposite midpoints of the edges over here. Similarly, from this endpoint of the minor diagonal, join the opposite midpoint of the edges. Now once again, center point number 1, center point number 2, center point number 3, center point number 4 will be used. And now the first arc using this center has been drawn, the second arc using this center has been drawn, the third arc using this center has been drawn, and the fourth arc using this center has been drawn. So this way the inner circular projection into the isometric projection appearing like an ellipse has been obtained. The outer circular projection appearing like an ellipse into the front surface has also been obtained. So now we have to replicate these two circular projections corresponding to the remainder three surfaces over here. But one thing we need to remember, corresponding to this surface and corresponding to this surface, because it is going to fall after this thickness, it is going to fall after this thickness. So the inner circular projection will not be visible into these two walls over here. that is on the rear faces of the webs over here. So now into this side of the web, only the outer circular projection will be visible. Into this circular projection of the web, only the outer circular projection will be visible, whereas onto this side, because there is a gap, so certain portion of inner and outer circular cross sections will be visible into the third vertical web over here. So now we have to repeat this procedure. So in order to make the thing simple, now we have just deleted the construction of these two circular projections over here. So now we know that this is the same elliptical structure which we have to obtain corresponding to the second square surface over here. So using the same 4 center method, we are going to obtain an elliptical construction corresponding to the inner surface of the web number 1 over here. Now here we need to understand that only this portion of the circular web, it will be visible to the observer from this side, whereas this portion will be covered by this thickness of the first web over here. Now corresponding to the third surface, which is this surface over here, so corresponding to this third vertical surface, which is again having the dimension 60 by 60 square, so we can check the third surface is also having 60 by 60 square. So here both of these outer and inner circular projections we need to obtain. But once again, this portion of the web, this portion, it is going to cover this portion of web number 3 over here. So this portion of the web number 3, it will be covered by the thickness of this web over here. Therefore, only this portion of the surface number 3 will be visible to the observer over here, and corresponding to this fourth surface, once again as we have discussed, because it is lying toward the rear side of the solid, so we are going to obtain only the outer circular web over here. And once again, the total circular web, it will not be visible. So this portion, it will not be visible to the observer because it will be covered by this thickness of the web over here. So this way, corresponding to surface 1, surface 2, surface 3 and surface 4, we have been able to obtain different circular projections over here into the isometric projections over here. So let us start darkening whatever portions of the solid will be visible to the observer, as the observer is going to look at the solid into the 3D isometric projections over here. So we can check this surface will be visible to the observer. So it is this portion of the surface or the horizontal web which is visible to the observer. This portion of the web will also be visible to the observer. So this rectangular portion we have observed over here. Then this portion and this top portion, it will also be visible to the observer. So we can check this inclined portion toward the front side, and this top portion will be visible to the observer. And then this portion, that is corresponding to this horizontal element at the base and this vertical element over here. So this will also be visible to the observer. So the front portion corresponding to the horizontal element up to a length of 50 millimeter has been obtained. Now let's move on to this portion corresponding to the rear side face of the solid. So here we can check this portion is visible to the observer corresponding to the outer area. So 10 millimeter, it is the vertical height. We can check 10 millimeter, it is the vertical height which is given over here. Then the circular portion will be starting, and then we have a flat portion over here. So this is a flat portion. Then the complete inner hole on the front face of the solid, it will be visible to the observer onto this surface number 1. But regarding the surface number 2, this width we have to mark as 20 millimeter. So please check, this width we have already marked as 20 millimeter. So this width we take as 20 millimeter, and then only this portion of the circular cross section will be visible. that is the outer surface of the circular web will be visible to the observer. Then you have got, after a gap of 20 millimeter, surface 3 corresponding to the web number 2. So this is surface number 3 corresponding to web number 2. So now over here, these portions, they are not visible to the observer. Only this portion of outer and inner circular cross section, so this will be visible to the observer. So this is the outer cross section, this is the inner cross section, and again we can check this distance is equal to 20 millimeter. So this distance is also equal to 20 millimeter. This height is equal to 10 millimeter over here. Then again the width over here, it happens to be equal to 20 millimeter, and then the outer boundary will be visible. So from here we take a distance of 20 millimeter, and then this outer boundary will be visible to the observer, and again this is a 10 millimeter height over here. So this way we have been able to obtain the isometric projections of the solid when the orthographic front view and the top view projections of the solid, they were provided to us. So let us do the cleaning of this image so that we can get the better visualization of this 3D projection. So these interior portions of the circular arcs which are not visible to the observer, we have removed now, and now we can see the outer circular portion, it is having radius is equal to 30 millimeter, while the inner circular portion, it is having diameter 40 or radius is equal to 20 millimeter. So this is all for today. So I hope that through this discussion you would have understood about the procedure. How do we evaluate the isometric projections of an engineering object when the 2D front view and 2D top view orthographic projections of the solid, they were available with us. We are going to continue with further discussion regarding few more illustrative cases of isometric projections of the solids in the coming lectures. So thank you very much. Thanks a lot.